Welcome back to Chips and Salsa, where we talk about security at Intel. I'm Jerry.
I'm Krobe.
We have an exciting show today. We have a couple folks from Intel, Brandon and Rowan, here to talk to us about a new open source fuzzing tool they call Sisyphus, which I keep stumbling over. So let's talk to Rowan and Brandon. Well, Brandon and Rowan, thank you for joining us on Chips and Salsa today. Can you both introduce yourselves and let us know what you do here at Intel?
Yeah, sure. My name's Brandon Markin, and I'm a security researcher here at the SPM Red Team. And I work on finding technical and educational solutions to security problems at Intel.
Nice.
Cool.
And my name's Rowan Hart. I just graduated from Purdue University, and I'm also on the SPM, which is Security, Privacy, and Mitigation Red Team. And I'm primarily working on fuzzing, specifically at low levels, so firmware, kernels, operating systems, and other software.
Nice, right out of college.
Love it. So we just published a blog that's titled, "This Hardware Doesn't Exist." Can you maybe provide us a high-level summary of what that paper covers?
Yeah, I have to thank Rowan for the title there. At Intel, we have a lot of low-level software, firmware and drivers especially, and they run on pre-silicon software. So there's this software that's still in simulation. And so it has to run on simulation because the hardware isn't put into production yet. We still want to thoroughly test that software, though, before it hits the hardware and really before it is published and released. One of the tools we have for this is fuzzing. And the current state of low-level fuzzing is very fragmented. It has a lot of bespoke tools that only work on one hardware solution or one area. And with this post, we wanted to introduce a tool we wrote called the Target Software Fuzzer for SIMX, or TSFFS, which we pronounce as Sisyphus, like the character from classical mythology. And it's a fuzzer which uses the Intel SIMX simulator to fuzz software that's still running in simulation, or rather running on simulated hardware.
Nice. Sisyphus, is that correct?
Sisyphus, like Sisyphus.
Right.
That's
awesome. So what's new or unique about this?
So there are a lot of fuzzers out there and a lot of low-level fuzzers at that. This was unique in a few ways. The first is that it's integrated into the Intel SIMX simulator that many teams at Intel are familiar with. In fact, I would wager a huge chunk of the hardware teams are familiar with it. And it unifies fuzzing from boot all the way to user space into one tool. You can simulate everything from UEFI all the way to user space to software with SIMX. And now you can fuzz anything that runs in SIMX with our tool Sisyphus. And again, it also allows hardware or fuzzing for hardware, fuzzing software that runs on hardware that exists only in simulation. We don't know of any other tools out there that do this beyond, again, small bespoke tools. And it's written entirely in the Rust language, which makes it really, it's, we have some, or Rowan rather will have some things to say about that one because he had to add a lot of support for that. And those are the big things we wanted to hit on.
Nice.
Awesome. So, thinking back, and maybe Rowan can touch on this, what were some of the challenges that you set out to tackle, and how did you overcome them through the execution of the project?
Yeah, so kind of the main thing that we wanted to tackle with this project is usability. So there's lots of fuzzers for lots of different software domains, from existing UEFI fuzzers to existing kernel fuzzers and so forth. But a lot of those fuzzers, are not really oriented at hardware teams. So teams developing drivers, teams developing, pre-environment initialization drivers for UEFI, things like that. They're more intended for security professionals, and we wanted to sort of bridge the gap in capability between, offering the same utility that security professionals are using, but in a tool that driver and low-level software developers are already familiar with and will be pretty easy to set up, and fuzz software that already has fuzzers, but those fuzzers are generally pretty complicated, very specific, and we sort of wanted to unify the usability and the user friendliness of kind of fuzzers across that stack. So the user perspective is sort of the main thing that we wanted to keep in mind while we were developing the tool. There's a couple other things. So one is we didn't want to reinvent the wheel as far as fuzzers go. So there's a lot of fuzzers which are essentially forks of sort of an original fuzzer by Michal Zalewski called AFL, American Fuzzy Lab. And now there's a new library which implements a lot of the ideas as far as fuzzing goes. So getting information out of your software while it's running, figuring out what coverage of your software you have, mutating inputs to explore more paths through that software. That library is called libafl, which is written in Rust. And so wanting to use that library was essentially the motivation for us writing this entire project in Rust, which, to overcome that, we actually had to add Rust support to the Intel CMX simulator itself, because there wasn't just no support for it. There, in the words of developers, really wasn't support for it. So we went ahead and created bindings for Rust to the simulator. We now have an entire ecosystem for developing modules for CMX in Rust, not just modules for fuzzing, but anything that you could want to create. So we ended up kind of going beyond our initial objective in that sense.
Well, gold star for using a memory safe language.
Thank you.
So,
Trying to set an example.
Yeah. So do you guys have a roadmap for Tisifus? Like what's next for the software?
Absolutely. So right now we've published all of the code open source. Open source developers can pull it down, build it themselves, run it on our public distribution of the Intel CMX simulator with packages from, older Pentium processors all the way up to Sapphire Rapids processors in simulation. And that's all publicly available right now on GitHub. In the future, the main thing that we want to support, of course, internal teams. So additional architectures that teams internally are using for our accelerators and off-core hardware devices, as well as some new fuzzing techniques. So we currently support just about everything that libafl supports out of the box. So we have feedback from the target software execution. We have feedback from comparisons executed by the target. So if you have, if your loop counter equals 10 in your code, then the fuzzer will see that comparison execute and say, okay, maybe we need to do something 10 times, or maybe we need to add 10 to our input to try and, explore new paths through the code. And we want to go a little bit beyond that and add things like sanitizers, so detection of memory errors at runtime, even beyond memory errors that cause CPU exceptions or trigger assertions, both of which are built into the fuzzer. We want to enable more use cases for continuous integration. So teams which are working on firmware and kernel drivers and things like that can start to fuzz test their software more easily in their continuous integration system. So every time you push a change to your driver, a fuzz test gets kicked off, runs for 2 weeks or whatever the case may be, so that we can be a little bit more proactive in terms of allowing developers to easily catch those low-hanging memory errors. And of course, some research topics. So we want to look into adding more symbolic execution, adding more taint analysis, things that will improve the effectiveness of each cycle of our fuzzer, obviously, because it runs in simulation. It doesn't run quite as fast as something like libfuzzer, which runs on your system and just executes in a loop. We have to restore a snapshot of the entire simulation. So we really want to try and pursue research with our tool that makes our executions count.
Mm-hmm.
Jeez, that's pretty amazing.
Yeah, it is. So you mentioned that the project is out on the Intel GitHub repository, and would we look for the Tisifus name? That's how you'd search for it?
Absolutely. So it's github.com/intel/tsffs is the best place to find it. There's lots of instructions on there on how to build it from scratch. Eventually, we plan to release binaries externally so people can just pull it down and install it instead of having to build it. But we have full instructions on there for running it on Linux, running it on Windows, running it in Docker container. So we hope we're offering some flexibility. And linked from that repository is our documentation, which has some use cases, including setting up the fuzzer and running it to find a fun vulnerability which recently came out called logo fail, where the boot logo of your machine could cause arbitrary code execution. So we've provided an example of modifying some Intel firmware because it actually wasn't vulnerable, but adding the vulnerability into our firmware and then finding it. So there's some fun stuff like that on our documentation that should hopefully get people kickstarted on using the fuzzer and trying it out for their own use cases.
And it's having gone through it recently, it's very, very thorough.
And if somebody from the community was interested, can they leave comments or file a PR in your repo?
Please do. I hope to see PRs in the future. I love to see issues because it gives me things to add to my roadmap for the next quarter. So problems.
That's what we're using as our I guess as our tracker for what topics we have to add into there. So
that's awesome.
Awesome.
Congratulations. Well, that was great work.
Yeah, you guys wrote a pretty extensive blog. We'll put it at the link below here where viewers can go and get some more information. So good luck with the future endeavors with Sisyphus. Sisyphus, did I say it right? I'm going to say that one 5 times fast. So great work, guys, and thanks for coming on the show.
Thanks so much for having us.
Wow, Jerry, if I like something more than open source, it's open source fuzzers, because I am fuzzy right now. That was an excellent talk. Brandon and Rowan releasing this amazing tool to the community. Yeah, it's pretty awesome. And so, we showed the link. Go check out Sisyphus and give some feedback to these guys. Thanks for joining. That's all for this episode. We'll see you next time. Later on.